A discussion between Raju and Rajesh about real numbers. Rajesh, are all integers also included in real numbers? Why? Yes, Raju, I will explain you by taking a number line here. The real numbers are the set of numbers containing all of the rational numbers and all of the irrational numbers. All the integers are included in the rational numbers, since any integer z can be written as the ratio z by 1. The real numbers are all the numbers on the number line. There are infinitely many real numbers, just as there are infinitely many numbers in each of the other sets of numbers. But it can be proved that the infinity of the real numbers is a bigger infinity. Thanks, Rajesh, for explaining the topic. Exploring real numbers. Click each tab to know more. Let us first know about prime numbers and composite numbers. Prime number. A prime number is any number greater than 1 and has exactly two factors, 1 and itself. For example, the numbers 2 and 3 are prime numbers since they have factors 1 and itself. Some more prime numbers are 5 and 7. And the number 4 is not a prime number since it has more than two factors as 1, 2, 4. Some more examples which are not primes are as shown on the screen. Composite numbers. Composite numbers are the numbers which have more than two factors, that is the number 1, the number itself, and at least one other number. Examples are as shown on the screen. Note: 1 is neither prime nor composite. We know that all natural numbers except 1 can be written as a product of their prime factors. For example, let us go through some of the numbers. Say 3 is equal to 1 into 3. 6 can be written as 2 into 3. 253 can be written as 11 into 23, and so on. But here 1 is neither a composite nor a prime. Can there be a composite number that isn't the product of the powers of primes? For this, let us take an example of factorizing a large natural number 163800. Let us use factor tree that is well familiar to all. Now, let us have a look on some of the natural numbers. 163800 can be written as 2 into 81900, and 81900 can be written as 2 into 40950. 40950 can be written as 2 into 20475, can be written as 3 into 6825. 6825 can be written as 3 into 2275. 2275 can be written as 5 into 455. 455 can be written as 5 into 91. And 91 can be written as 7 into 13. Here factorization of 163800 as shown. Therefore, when we write the above terms in terms of product of powers of primes, we obtain as shown. Let us try with another number. 1, 2, 3, 4, 5, 6, 7, 8, 9. This can be written in the following form as shown. Here the numbers 3803 and 3607 are primes. By this we can prove that a composite number can be written as the product of primes. Here are some examples as shown on screen. If the numbers taken has all the possible primes, what would be the size of the collection? Will it contain only a finite number of primes or infinitely many? It is infinitely many. Therefore, if we multiply all these primes in every possible way, it produces an infinite collection of composite numbers. The following gives us the fundamental theorem of arithmetic that tells every composite number can be factorized as a product of primes or given any composite number. It can be factorized as a product of prime numbers in a unique way, except for the order in which the primes occur. Take an example for this. Take a number 210 and factorize it. We get product of 2, 3, 5, 7 as same as product of 3, 5, 7 and 2, or any other possible order. By this we conclude that there is only one way of writing the product of primes. Now, let us state the fundamental theorem of arithmetic.